If you have ever been handed a problem on a project without a clear definition, scope, or cause, this episode will completely reframe how you approach problem solving. Because in project delivery, it's not just the big fires that derail timelines. It's the hidden, recurring process issues no one stops to properly define.
Knowing where to start is an important part of any problem solving, so I always go to understanding the documentation.
Most teams treat symptoms, but if you want to consistently deliver projects that perform, you need to think beyond putting out the fires and start mastering the structured problem solving.
You've got to know the process at the start. And if you don't know the process, and if you haven't got a standard, what's the problem?
Enter Mark McLean, a seasoned consultant with decades of experience in engineering, quality systems, and ISO standard development. He has worked with the BHP, Downer Group, Qantas, even biomedical labs. And today, he's sharing the exact framework and stories he's been used to help organizations identify root cause and create sustainable improvements.
So one of the things about clearly defining a problem is collecting the data. You got to get the evidence about what is actually the problem.
In this episode, you will learn how to define problem with precision, use practical tool and process-based cause analysis, and why following your own procedure might be the most underestimated productivity hack in your business. Let's go beyond the plan. Good afternoon, Michael. It's really great to have you here today, and I'm really happy that we are talking about problem solving today. But before we dive into this very interesting conversation and unpack a lot today, tell us a bit more about yourself. Who is Michael McLean and why people should listen to you?
Oh, well, I was born in far north Queensland, so you should always listen to a far north Queenslander.
That's a good answer. All right.
That's a difficult question in some ways, Ali.
Yeah.
I've been doing problem solving for many years as a tradesperson, and then I went into business as an engineer and everything.
Yeah. And
then I became a management consultant after working in many companies.
Sure.
So, and all the time that I was working as a industrial engineer, production engineering, and then HR and quality, I kept on coming up against problems. And then I went to a course, and then I was doing my degree, and I thought, oh, this problem solving, it seems to be like pretty popular. And I was kind of learning this from many companies and many consultancies. And I find through my years of consulting, that's why I don't have any hair, that every time I go into an organization, I try to understand the problem.
Yeah.
And then with respect to what they do in regards to their problem solving, I use whatever they use.
Yeah.
But then in the end, I decided that I'd try to summarize what I thought was kind of the consolidated view of different methods that people do in problem solving.
Yeah.
And so my consulting career is both here in Australia and internationally. And what I'm going to share today are a few techniques that people have used around the world, but also across many diverse Australian industries. So I'm very excited to share that information with you in just 5 steps.
Amazing, amazing. I mean, can we even find a human being that doesn't have a problem? And when we talk about the problem solving, I think we have got everybody's attention here. So if they listen, then they could be able, they would like equip themselves hopefully with the right way to basically solve problem, at least a good systematic engineered approach basically to tackle any sort of problem, either it's in the career or if they're working with the big projects or anyway, it doesn't matter, because problems are problems. But I guess what you're going to tell us and teach us today is basically how to systematically approach that, isn't it?
Yes. And I'm not of any particular bent about what methodology. What I'm sharing today is just what I found useful to complement whatever the organizations use as their own problem solving method. Yeah. So as a management consultant, I use this in my back of my head, so to speak. And then when it becomes embedded, they say, oh, this kind of works. And the methodology I'm respecting is actually Dr. W. Edwards Deming, because many people thought that this plan, do, check, act cycle,
the PDCA.
I represent the ISO technical committee, which is on ISO 9001. I go to Mexico in a few weeks' time for the revision. And ISO still uses Plan, Do, Check, Act, which is actually something that the JUICE, Japanese Union of Scientists and Engineers, Dr. Ishikawa, but not the one that we all know of, try to interpret the complex problem-solving method of Dr. Walter Shewhart. So to summarise it, and Dr. Deming turned up in 1950 after two other guys, Saracen and Protzman, were there, and they summarised Shewart's kind of problem-solving method as Plan, Do, Check, Act. Well, Dr. Deming never called it that, but because Deming was there, they thought, oh, it must be his, but it wasn't. And anyway, Dr. Deming, and which I now have affinity to because of my studies, he called his cycle Plan, Do, Study, Act, because you study and you learn about a process. You study a process behaviour.
Yeah.
And so today I will just share what kind of is my learnings, similar to what Dr. Deming did, about trying to improve a process, but you've got to know the process at the start.
Sure.
And if you don't know the process, and if you haven't got a standard, what's the problem? There's a English cricket team out at the moment, and they've got a few problems, but that doesn't mean that they won't solve them. But I'm sure that they're going through some very deep problem-solving methodologies to try and rectify that.
So we have got their attention here. As
they've got their attention.
That's awesome. That's awesome.
We can speak in an English accent, so we can actually make sure they do understand it.
Didn't expect that.
No.
No, that is good. That is great. So, evaluating problem solving. Where to start?
Right. I kind of alluded to it in respect to this. So this is a methodology which is based on this thing called DAXIS, and I'll take you through that as we go about defining the problem, making sure that you assess the scope and some of the things about the causes of it. The cause analysis is where people trying to get a bit funny about the problem. And then the other C is actually collecting the data. Now, collecting data is something that people now, when we heard about the COVID pandemic, you remember the days when people said, oh, it's COVID, the data says, or the facts are, and then they started to change it to saying the evidence. And so the medical people and the government started to talk about the evidence. So when we'll start on this, and I'll start drawing it pretty soon, you got to get the evidence about what is actually the problem, and your documentation should tell you that this is where we start from. So the third step we go through later on, which is in developing so-called a data collection plan to make sure we have got the right causes and the solutions and implementations, we put it into the system, and the last part is we standardise it. So that's the kind of the DAXIS methodology, and that's captured in our problem-solving Australian-made licensed product.
Nice.
Now, where to start? I remember my automotive quality manager, I was there when he had this person, or two people come into the factory, and they said, oh, we got the problem out in the factory. This is always a problem, and this guy always does it. And this manager, he was an English guy, up on his whiteboard, he had, show me your PFMEA, show me your process failure mode and effects analysis. Because every time somebody had a problem, a cause and a problem should be documented in your process failure mode and effect analysis. And that's the idea. It's a problem prevention technique.
Sure.
Anyway, they go, oh, okay. Oh, look, we'll go out and collect the data, and when we come back, we'll still prove that he is the problem. Okay. And then I'd wait there, and a few hours later they come back, and he said, oh, how did you go? Oh, we looked at the standard. So one of the things which I just moved this book away, this is when you have a look at the standard, is there's some kind of a standard, and it could be a document, it could be an SOP, it could be a safe work method statement, it could be a work instruction. And that work instruction tells you what you're doing.
Exactly.
So if you got a problem, it should have been identified by whoever wrote those documents in there. The second part is if you got the data, or if it's an American presentation, we have the data, And so what had happened, we've had this kind of a standard here, and we have a deviation or a variation from the standard. Something changed.
Exactly.
How did you know that something changed? So in the lean manufacturing language, they talk about Gemba or Gemba, whichever school you went to, go to see. And I learned that from being trained in work study, work simplification, industrial engineering. So as a consultant, I still do the same thing. I have to go out and have a look. So the same thing. Have you got any documentation? Have you got a standard? Where is the variation?
Yeah.
And if I use another biomedical client, they make DNA products for mice, and I'll just show you that they had 9 steps in their process, and they had all these columns in a column chart. And these are the 6 of the 9 stages of their processes. And I said, oh, what's the variation? What do you mean the variation? Well, what's the scale? What's the scale that you use? So scale, as we know, is important.
Yep.
And so this is all a public knowledge. So I'm not telling you something confidential here.
Yep.
They found that the average was about 120 weeks to make this biomedical research mouse for medical research around the world. Wow. And I thought, and so when I said, well, is that the average? Yeah, but that's only at step 1. And I thought, oh, if that's step 1, what's the average for step 2? And it was like 100 weeks. Step 3, I went, and it went less. And I said, hang on, you've changed this. You've used, hang on, have you got the same scale? And so what I did a bell curve. So when I did the bell curve, I'll just colour it in like that. I said, oh, you've got variation. So the average is 120, yeah. But you've got some, what are these columns? Oh, they're the project. Oh, right. If they're the project, what for each client? Yeah, like for pharmaceutical companies like AstraZeneca, Pfizer.
Yeah.
And they said, yes. So your average is 120, which means you got projects at 150 and some are 40. Was that 40 weeks? Yes. So you can do it at 40 weeks, yeah, but you've got variation. So this variation is deviating from there. And I said, so how do people do that? You'll love this. They have a step by step. And I said, SBS, not the television company.
Yeah, we're not promoting them.
They're not promoting
Not today, okay.
So they said, yes, we follow step by step. Oh, you've got documentation. You've got standards. Yes, we've got a standard. Oh, fantastic. Well, why don't you follow it? Why did you say that? Because you have so much variation. Something's changed that you're either not following it, or the technology's not right, or the laboratory's not right, or the computer's not right. There's something that's not right for the operator, in that case scientists, that they couldn't do what they wanted to do because there was something else wrong. And we cover that later on regards cause analysis.
Yeah.
So, yeah, knowing where to start is an important part of any problem solving. So I always go to understanding the documentation. And I suppose what happens is to keep doing what you're doing, which we talk about later on.
Sure.
Keep doing what you're doing is about 70%. Working at what to change is about 20%, and I say about.
Yeah.
And of course, the last part is create, which we have an Australian-made trademark actually. So keep doing what you're doing because you've been pretty successful. You must be doing something right, yes. Yeah. But now you've got competition, you need to fix it. So understanding where to start is an important part. And once you know that, gather the evidence and getting people involved in that, not to blame anybody. So the purpose here is not to focus on the person, it's to focus on the process.
Of course, because people follow the process, isn't it? As you said, there are like work order statements, instructions, how to do the things, and all the rest of similar documents that we have got like in all over industry. And people are simply following those, isn't it? You know, when they are part of a process, they simply following that. So if there is any issue or problem, as a starter, we have to go back to those manuals and say what's exactly in those manuals. Are they following that or they not? And if they're not, or there is like deviation from standard procedure, why are they doing that? But when we're looking at like the high level of the things, and we see that, well, that particular unnamed company is a successful company. Yes. So as you said, and I like that, the analogy that, okay, we're not going to like chop and change the whole thing. We're not going to rock the boat. We're going to keep 70% of what you were doing because we still don't know, but we could understand that you have been doing something or to some extent right, but the rest needs modification and change. So let's keep the 70% that is working, okay, as it is, no problem with that. Then let's focus on 20% that we think, okay, this is where the issue, the problem has arisen. Let's change that, and then 10% for creativity as well, and see how it works. So going through the same cycle of the PDCA, as you mentioned earlier, to some extent, isn't it?
Yeah, and so if people go in, if they're using, as you rightly said, Ali, if they're using just then plan, do, check, act, or they're using 8D, or they're using a lean, like the Deming thing, plan, do, study, act, or they're using Six Sigma to make.
Of course.
Yeah, so whatever they're using, and they deviated. Dr. Tom Peters back in the 80s in The Search of Excellence, he said it doesn't matter what type of methodology or discipline you do as a management team, just follow it.
Yeah.
Because if you follow it, you'll be fine. Professor Imai from Kaizen, I saw him present, and I was at BHP Steel, which is now unfortunately closed, up in Newcastle, and they had the Imai books, they had the Kepner-Trigo books, they had many books about problem solving, and I thought, which is actually referenced as one of my testimonials.
Sure.
So BHP, I said, a bit like Dr. Duran. So when Dr. Duran was called in after Dr. Deming was told to leave in 1953, Dr. Duran said, oh no, what Dr. Deming was doing was right. He was following Saracen and Protzman and all these other people.
Yeah.
So the Jewish people in Japan was like, but we had all these problems with Dr. Deming. He said, why are you saying follow Dr. Deming? He said, well, I'm Duran, and what Deming said was fine. It was just maybe the delivery was different. And also they had problems of understanding statistics, understanding that quality was everybody's responsibility. And I know this seems strange, but he found that the Japanese had lost that creativity and innovation because they kept on following statistics. Now, that seems all funny because the research says, like Simmons in his book on levers of control, some of the most productive and innovative and creative companies in the world have, as you said, Ali, strong following of process and procedures. And like Einstein and everybody else that's a scientist, not like us, mere mortals, but they write down, like Madame Curie, one of the few people that's a woman too, that got a double Nobel Prize. Oh, yeah. She recorded every experiment. Because unless you know the document and you didn't have a record, you don't know where you started from.
Exactly.
And was it Alice in Wonderland where Alice got to the fork in the road and she looked up and she said to the Cheshire Cat, oh, hello, I was wondering, could you tell me which way to go? And the Cheshire Cat says, sure. Or where do you want to go? She responded, well, I really don't know. And he says, well, it doesn't matter which road you take, which fork in the road, because you don't know where you want to go. So those procedures, as you said, Ali, are kind of important. They tell us that that's what management gave us. That's what we should follow. And if we're going to follow it, follow it. And if it doesn't work, at least you know you can blame the procedures, not the person.
Yeah. I followed the document, all right?
Yes, that's right.
If anything needs to be changed, let's get the version 1.2, okay, shall we? So then we back hopefully on the right track. No, amazing, right? So that's basically where we start. And then moving to number 2, how to clearly define a problem, because that's a part of it, like identifying the problem, isn't it? If you don't know how to identify that or how to spot that, then what exactly are we addressing?
And this is the issue about the word problem, because when you clearly define it, it's like you say, a major hotel in Sydney, I was called in because they had problems, which I didn't know about until I got there, about client or hotel guest satisfaction. And so I was called in as an expert about the problem. So I had to clearly define it. Yeah. So when I had the 35 people down there in Sydney overlooking Sydney Harbour at Circular Quay, I had all the different people in there and I said, so what's the problem? Communication. Is that the problem? Is that why I'm here? Yes. So I said to the first person, where do you work? Oh, I'm the concierge. Oh, okay. So what do you think is the communication problem as you as a concierge? Well, the people down in the parking don't tell me where the parking spots are free so I can direct the parking attendants to go to the park. Oh, who are you? Oh, I'm the staff canteen restaurant person. Oh, so you got a communication problem too? Yeah. What's your problem? Oh, people complaining about the menu. So by the time I went around, I said, what's your problem? Oh, I'm the house cleaner. I said, so what? Sorry, I'm getting 35 different problems and it's all about communication. Yes. What's the problem? And they said, oh, I see what you mean. So one of the things about clearly defining a problem is collecting the data. So in what we do now in regards many things is trying to collect the data. And in trying to collect the data, you have to do it so you don't have a perception that you have to get the data to prove that you as a senior person can prove that somebody else lower than you is wrong. It could be going back to you. So my father was a toolmaker, and so was my uncles, my brother. And he always said to me, you know, be careful about pointing a finger at somebody because one finger goes to them, but there's three fingers going back to you.
Oh, yeah.
So with respect to defining the problem, it's going to make sure that, okay, where is the problem?
Exactly.
And in lean, they call it gemba. And depending on if you're Japanese, it's gemba, as in with an N. So you go down and have a look. So when you've gone to have a look in regards where to start, you've gone into the office or back to the hotel or wherever you are, the factory, and you go to have a look. And when you go to look, if you're going in with a clipboard or a camera, sometimes the cameras are good. Sometimes the clipboard's good, but it's the ability learning to see. So when we go in to clearly define the problem and you've gone into where, and then you say, right, what is the area we're looking at? So what is the scope? What are the boundaries?
Exactly.
So sometimes, and I've seen this too many times with managers, they pick a project for the team to work on, but the scope is so wide and long that there's no way they could focus on it. I remember up in BHP up at Octetti, John Grubb, I can mention his name because they fixed it. He did the so-called terms of reference. He wrote it out because he knew where the problem was out in the mine. I was a few thousand metres up in Papua New Guinea. But it was interesting about the boundaries. He wrote out the boundaries in a terms of reference. And he did it because he wanted to make sure what is the area. And then when he defined it, he said, look, we want to make sure that it meets a criteria.
Oh, yeah.
And the criteria could be on quality, no bad Q, sorry.
That's
cost, could be on delivery. And up in BHP at Octetti, could be on the environment. It could be about meeting sustainability goals. It could be meeting in regards to delivery on your schedule. And you've run many sessions with what you do here in regard to production planning, scheduling. So there could be many reasons why people have it, but you need a criteria to then say, righto, here's all these problems, and we list them. But how are we going to list them and then make sure that people do them, you know, pick the right area in the boundaries? So then that's when we came up with this FO. So my friend regards FO. So we thought, okay, if we know about it, that this regards the FO, what is the fault? Not the person.
Yeah. Process.
What's the object we're looking at? So where did you go? And the important part about that data, what's the extent? And so you start thinking about the fault, trying to define the fault. In a white goods company, which we had in Australia, we still have a few, but not many. I was called in because the ladies on the production process had all these kind of sticky tape things on their uniform. And I said, oh, what you got the sticky tape for? Oh, it's actually masking tape. Oh, well, what do you do with the masking tape? Oh, we put it on the defects on the fridges. How come you got so many on your arm and so many on this arm? Oh, my left arm is from when I start at 7 a.m. to morning tea. But you seem to have a lot on that one compared to the right one. Oh, yeah, but then the production process warms up and the other people are warmed up and I get less defects. But you seem to know, like, is this what you do every morning? Yeah, every shift, yeah. But you seem to know that that's about the number of defects or the faults you get in the fridge making. Yes. So what do you put it onto the fridge? Yes, we put it onto the fridge. And so I got the general manager was behind me and he started laughing and all the engineers are going, oh, no. And so when we went out to the production line, these ladies went up, yep, it's true. They were finding faults in the fridge. And I said, you're very skilled. How did you know where it was? It always happens here. It always happens on this thing. It happens on this side. Oh, you know where it happens? Oh, yeah, it happens all the time on this particular model. Oh, you know the model? I said, yeah. But on this model, there's other defects. And I was like, I don't believe this. And so the manager said, that's why you're here, Michael. And I said, So knowing where the fault is.
Exactly.
And you can do a drawing, go back to your procedures. If you've got a thing called a process control plan, a process control plan is a plan to control the process. And sometimes they have boxes and flows, but they also put a picture. And so what we did, we went to the documentation, said, so you know where this is? And they did. I said, okay, so this is the object. It's what type of fridge? What's the number of the fridge? Oh, it was model 1. It was model 7, model 10. Oh, okay. Or if you're in bank, doing bank assignments, it's in this mortgage document. Or it's this in a policy document.
Oh, yeah.
So you need to know what you mean when you say the object. And of course, the important part is the extent. So, it happens. It happens all the time. When? It happens every month. Okay. When in the month? Usually the end of the month. It happens the end of the month. When at the end of the month? Well, the end of the month close down or shut off when I close the books. You close the books? What do you do? I close off all the books here in Sydney to send it back to Westinghouse, for example, over in the United States. And they've closed this plant, so I could talk about it. I said, why did you say at the end of the month like this? He said, it happens in the last 2 days of the end of the month. So I said, so what you're saying, the problem only exists, in the afternoon of 2 days per month. So it's like, 6 hours? Yeah. So it only happens 6 hours a month. Yes. Oh, yeah. That's not very much, is it? I said, well, no, it's pretty important. Where does this information go? He said, well, it goes to the United States. Well, why does it always come in late? Because our templates and our computer doesn't do this and that. And by the time she was talking about it, the manager said, oh, no, it's the computer system. And she went, what about it? So they fixed up the computer system and everything was fine.
Wow.
So, understanding that what we call the foe, it's not necessarily the only thing you can use to define a problem, but it does help.
Absolutely. No, very good analogy and very good sort of, a structured way, 1, 2, 3, to identify and go through that one by one. Nice. So next one we have got, do you or your team know enough about the problem? Let's unpack that one, Michael.
So one of the techniques that people talk about in lean manufacturing is they talk about the 5 why. Now, in industrial engineering and work study, that is true, but I'm going to do something here which a lot of people watching this will think this is terrible. I'm going to put a line through that.
Right.
So Rudyard Kipling said, I have 6 honor-serving men. I wonder who they are. Well, I've kind of alluded to it here in regards, where is the problem? What is the problem? Like we did the foe.
Yep.
So go to Gemba, as we just did. When did this happen? Remember the lady with closing the end of the month?
Yep.
So there's something about the end of the month in regards to the timing.
Yep.
It happens on the back shift. Does it? So at a company which makes oils, edible oils, they make margarine. So one of my first management consulting assignments was in a margarine making company. So my boss, we were at the WD Scott at the time, which is the first management consultancy in Australia. He said, look, I got to go home. I got to cook dinner. I said, I'm going to stay here and I'm going to watch what happens on the afternoon shift when the day shift changes to the afternoon shift. Then what? Well, I'll watch it and then I'll come back and then I'll see the afternoon shift hand over to the night shift.
Yeah.
Because I want to know when it happens. So what happened was, and I can draw it because it was quite funny. So on the day shift, the process was like this. And on the afternoon shift, I'll just say it's like this. And the night shift, it was back up to about here. And I said, so what? There seemed to be kind of the world-class quality is on target with minimum variation.
Yep.
So the target was actually down here. I said, why does it, day, afternoon and night? Why do you guys do this? So I came back the next day and I watched it. And what happened was the machines and the technology was so advanced that the people wanted to touch something. They wanted to show that they're working. So when they changed shift, they wanted to show that the other shift didn't probably do it right. So they adjust all the knobs and modules and all the things to show that they're
perfect
working.
Place
they want it
as a start, isn't it?
Yeah, and I said, so I watched it, and I went, oh, so you're touching the knobs. Why did you do that? Well, I have to do this for my job. Yeah, but why? Going back to the procedure.
Yeah.
Why did you touch it? Oh, because the reading has to be 500 kilopascals or something. I said, oh, okay. If you know that, where's the notches to show that it's 500 or whatever? Yeah. Oh, they've been worn off. You know what's going to happen now, Ali. You're there going, so how did you know to move it that much? Oh, that's what we do every night. I know, I saw you do it. And then the other shift comes in and they change it back. Oh, they don't know what they're doing. We know what we're doing. And I thought, anyway, but in the end, we standardized it. We put the liquid paper on it to show that when you come in, just follow the procedure, set it up on the knobs and all these other instruments to make sure you have a standard. Yeah. Just follow it. And of course, you know what's going to happen. Yeah. When they came in the next day and they didn't know what to do, this process got stable, because that's the first law in statistics. Exactly. Making sure you are stable before you go into capability. So in regards the bell curve and the upper specification limit and the lower specification limit. And in here you got the variation, or what they call the process behaviour, which goes back to our Dr. Deming about Plan, Do, Study Act. You study the process before you go to capability. So capability is important, but you make sure the process is stable. So back to what we said. What? Yeah, where, when? So I've come, Now I'm going to be a little bit funny about this, is who? Who was the person assigned to do this particular job? Yep. Because you got to know who's doing it, but it's not to blame the person, it's knowing who was involved in this process. Of course. And the manager or the process owner should know that. That's in ISO 9002 actually, process owners. Some people in banking and insurance call them risk owners. So then the other part is, how did you do it? So there's the how, back to the procedures. Yeah. How did you do it? So we go through the procedures, and then the one I've left off is why. And I'll get to that in regards to the next one. But what we leave out is why, because do you know enough about the problem? But you don't do the why, because the why covers up in regards to the next stage, which is cause analysis. But a lot of people doing 5 why analysis start doing the 5 why on the problem, not the causes. So in Toyota, in Toyota's practical problem-solving methodology, if people go to the Toyota practical problem-solving methodology, you'll see, I think they're pretty good at solving problems. Oh, they are. I've had Toyotas for the last, since 1996. And they're still going. My wife's got a 2004 model, and the mechanics hate it because hardly anything goes wrong with it. So in regards problem solving, I think it's okay. I've got the newer one, of course. But saying if they've got a practical problem solving methodology, it must be okay. So in their problem solving, all the things that we've talked about here in this session is about kind of understanding the situation. They call it grasping. Grab hold of the situation. Of course. And when you grasp it and understand it, when I worked in Nissan over in Tokyo, in Parma, and then in Nissan in Smyrna, Tennessee, and then I've been in other places in England and all around the world, the idea is to actually go into the factory and just stand in a circle. Go to the abaya, go to the room and just watch. And when you watch, listen and look up, you'll see so many problems. And you go, my goodness, why are they doing that? But don't say anything, just observe. Observe and grasp the situation. So understanding that Toyota don't do 5 why, which is in Jeffrey Leiker's book, until after they've done a grasping of the situation, which leads us on to the next stage.
Absolutely. So just to sum up number 3, about the team, and if they know enough, not just jumping to conclusion, but go and absorb as much as possible, just like a sponge, absorb as much as possible. Where, what, when, who, and how. And then going to basically 1H. What was that?
Yeah, so yeah. And the so-called 5Ws and 1H, which is Rudyard Kipling's, or Rudyard Kipling, sorry. He had I have 6 honor-serving men, 5 Ws and 1H.
Yeah.
Now, it depends which school you went to. It's either H or H, but that's another story. But yeah, so the 5 Ws and 1H, I think as a management consultant or an engineer or anybody, if you just have that as your technique, but not, if you go into a situation, what are you doing? When did you do it? Not that way, but if you just kind of gradually go in and just understand what's happening. I had to do something for Qantas and I had to do a risk review for them at one of the jet bases. And I spent like the first 3 days just observing because I didn't know anything about servicing planes, but I was told to do this risk review. That's fine. But as you said, I'd left off the why until I got the data.
Exactly.
And then they said, we've got Bill Clinton and John Travolta arriving today. And as soon as that happened, I knew what the problem was because it was clear to everybody what the problem was. And, right. But they have to own it.
Yeah.
Not the consultant. No. And it's the people who have to solve it, have to own it.
100%.
But all we do is facilitate and provide techniques to help them to own it. Yeah,
100%. Going to number 4, cause analysis. So let's talk about that. I mean, there are lots of techniques around like fishbone and doing like the root cause analysis. We have got it in manufacturing, we have got it in projects, but let's unpack that, see what it's all about.
Yeah, so in Ishikawa's book, so Dr. Kaioya Ishikawa. So he had a book called The Guide to Quality Control. So I studied this back when I was doing my university, and when I was doing it, I studied this thing about quality circles. And so that was in the final year of my degree and all this type of stuff. And I thought, this is a pretty good fun thing. It was a worker participation from the Swedes, when they're making the Volvo and that. And so I got this book by Dr. Ishikawa, and it was pretty good. And he was saying, which is something which is kind of relevant for today, he said, if you understand the so-called 7 tools of QC, you can save probably about 95% of all problems. And that really hit home to me, Ali, because I thought, so what are the 7 tools? So people may know when they have a look at our book, but in regards to 7 tools, I was on ISO 10009, which is the quality tools guidelines. I was also on ISO 10014, which is the quality cost one and benefits.
Yep.
And I was on ISO 10017, which is statistical techniques. So these are kind of I'm nothing compared to the people that are on this. They're Boeing and Airbus and IBM, Cisco, nuclear facilities. So I always wondered when I get on these teams for ISO, why am I here? This why back to here. I always go, why do you want me here? I don't understand why I'm here. And it turns out I have other skills. Sure. But the reason I was saying that, and you asked the question about cause analysis.
Yeah.
So Ishikawa called them cause analysis diagrams. So what I found was people were using other techniques. And so what I've got over here are some things that people would be familiar with. Is like a post-it note. Yeah. And they just, put things on the wall in regards value stream mapping, what they do in lean manufacturing and so forth. But if you've got a few post-it notes and you put them up on the wall about some of the issues that you're not sure about, you think, what's the issues? We'll do ones in, say, red. We'll put up these issues in red. Why are they in red? That's to do with the laboratory. Okay.
Right.
Or we do them in green. Why? That's to do with the computer room. And so you're kind of affinity doing relationships. So you're putting all the issues related to a particular area. So the affinity diagram or the relations diagram is a very good way to capture things without putting any blame on anybody. Yeah. It's just trying to, does this thing around the issue, not necessarily the problem, it could be around the foe that we had up here. Let's say it was the problem. So we're looking at procedures, we're looking at the suppliers, we're looking at the policy written by the management. What are we actually looking at? And so the affinity diagram or relations diagrams enables us to kind of softly consider a range of issues. And I'll just mark this just to show people.
Sure.
So it may be that the causes of concern are actually the ones in orange. So as you rightly said, Ali, if they had the 4 areas, let's say the computer, the suppliers or something like that, so they become, interesting, they become the bones of the so-called basic fishbone diagram. Or as you said, a fishbone.
Yeah.
So those there become that, and as we've gone here, it's fitted into a fishbone. Now, back up to the foe, you've got to make sure that you have the foe here.
I see.
So you put the effect, the cause and effect, which I'll get down to Franken Furte later on. So this is what they call the so-called type A. There's a type A and there's a type B. So when Ishikawa realised that people would have problems with this, he called it the 4 M's, which is man. So we changed it to people eventually.
Of course.
It's, materials, methods and machines, to give people an idea of where to possibly look at. If you're not sure, just like the affinity diagram, relations diagram, it gives you some idea that perhaps we could have a look at that. So he said to guide you in that, if you do the 4 M's, that's fine. Then in his book, he said, let's say it's the managers are spending too long checking that the mortgage documentation is correct, like in a few banking jobs that we've done.
Yep.
And they go, oh, so what areas are causing that to do that? And you're not sure. It could be the policy,
of course,
that the company has got. It could be the IT system. It could be the people, but let's leave that. It could be the documentation, as we talked about earlier, Ali. So you're trying to classify it in areas which related to the affinity diagram. So we could still use the 4 M's or 3 M's and the P. Other people have added E for environment. So this is kind of a classification which is now, we've gone the 4 M's, which is A, and then we've done a classification which is B.
Yep.
Now, that's for what they call an event. So in a factory, when I was a HR quality manager at a spring making manufacturer in Sydney, we kept on having holes in the side of the factory wall. And I thought, what? And I only just started. I was only there a few weeks. And I thought, what are all these holes in the side of the factory? And they said, oh, that's the forklift truck driver. He doesn't know how to stack the springs against the wall.
And just
across
the wall.
And so he had the stillages and he had the tines of the forklift. And I said, how come that there's only holes down here? And then I looked at it, and then the guy, I remember we go to Gemba, he said, oh, I don't know, something's moved. I said, what's moved? And I looked down at the ground and there was a stop which had been pushed over and it had come undone. And that was his stop. So the other parts where they had the stop, there was no holes. Where it was moved, I know this sounds simple, but it was interesting because what I'd done, I'd spent $27,000 upgrading the fire equipment, regards people being trained in fire extinguishers, because I found also that they hadn't they didn't service the fire extinguishers properly as per the tags. So I spent over $20,000 doing all these fire extinguishers, and they had I'd got them all trained. I trained them in the 2 weeks. I got these guys come in, and the fire brigade came in. They checked out our furnaces and everything. So everything was right, and you wouldn't believe it. When they were trying to fix up put these blocks back in, I missed it. I was in my office, and next minute the fire alarm goes off. The forklift driver had gone through and he pushed it because they didn't install it correctly because we didn't give him the right tools to do it. He pushed a hole into the side of the factory. It went into the electrical cable. The electrical cable went up. It shorted it. It went into the computer control room in the factory. It caught fire. But wait, the operator, because he was trained in how to use the fire extinguisher, opened up the panel, opened up the door, walked in with the fire extinguisher, put the bloody thing out. Wow. So when he put it out, he said, oh. So the alarm had gone. The management and the board came down and they said, what, McLean, did you organise this? I said, no. I said, oh, so we stopped the fire. Yeah, I did that. I stopped the fire.
Saved the day.
And then, as you rightly said, Ali, why, how did this happen? And we followed the electrical cable over the factory and we went, no. And the forklift driver, he's driving around. He didn't have a clue that the chaos was inside. So when the event happens, and that happens in many companies.
It does.
Now that's A. That's type A and B. What about C? So whatever is said about here in regards our procedures and so forth, there's another one which comes in regards the process. So this is like a swim lane. And we all know about swim lanes. It tells you who's doing what in the process. And that goes into what they call the process cause and effect. So if I go around here, we just simply take the process, step 1, step 2, and step 3. I'll just do 3. Now, the same thing, this is an event. The forklift did something. There was an event, which is about 20% of most problems. Unfortunately, most people think that cause analysis or fishbones, which Dr. Ishikawa never called it a fishbone. So when I was in Singapore doing customer service for Changi Airport, they had the lion because they have the lion in Singapore. You go there, you see the lion with the fountain. Oh, yeah. I did a hospital in Sydney and they called it a sick patient diagram.
Sick patient diagram. Where did that come from?
A hospital in Western Sydney. Yeah. And then I did the Australian Meat and Livestock Research Development Corporation job. And you know what's going to happen? They did a cow diagram. And so when it was at BHP, they had Kobe Steel and Nippon Steel. And the maintenance people said, if we have one more Japanese tool or technique, we'll go on strike. And I said, oh my goodness.
Enough.
I said, enough. Anyway, it was they won the best team award, by the way. Yeah. So they said, oh, what's that? I said, oh, have you got a key ring? What's the key ring? Oh, it's a goanna. Oh, why don't we use a goanna? So we drew a goanna, a lizard, a goanna diagram.
Much better.
Now, when they did it and they went down to Melbourne, they got down there and they won the prize of the best team presentation in Australia. They beat Nippon Denso, Toyota, Nissan, Delcode, everybody. Wow. Yosaki, Mitsubishi, it built everybody. It's quite an achievement, isn't it? As Ishikawa said, you have to adapt this stuff to suit your own culture.
Exactly.
So if I'm in the Middle East and Saudi Arabia or Bahrain or somewhere else, I adapt all this problem solving and stuff to their culture.
100%.
Even as a far north Queenslander, I understand culture as a Queenslander.
So I was thinking maybe you're going to emphasize only again North Queensland. Okay,
no.
Not applies.
So if we look at step 1, step 2, step 3, and we start brainstorming the causes at each step in the process. So you need to make sure that your people understand that the effect is here. So this one is regards a process, and that's about 80%. As Dr. Tom Peters said, and many others, all work happens through a process, but sometimes things go wrong. So that's back to the failure mode and effect analysis. The PFMEA, they should have identified some of the issues that you'd have and also some of the causes. So the process cause and effect analysis is very important. And as we know now with sustainability and other things and understanding stakeholders, what we've also added in is a tree diagram, so to speak. So what happens with respect to the customer? What happens to the owners of the business? What happens to society? What happens to the employees as a result of our problem?
Oh, yeah.
What's the downstream impact? So we called it the DID. So the process is actually what it is. Now, back to what I put up here in regards to the 5Y. What happened to the 5Y? To use that company again, Toyota, once you do the cause analysis, you've collected some data. Make sure you go out and collect some attribute data. Sure. So it's important to get some attribute data, which is yes or no, it's that type of stuff, or some variable or trend data or evidence. So you collect the data to prove that this is the major cause or it's a symptom, which we get down to here. So once you've collected the data, you've agreed that's the major cause or causes, then you say, we'll do the 5Y on the highest ranked voted evidence-based cause. Now, if Toyota say that, I think that's a pretty good recommendation that your 5Y analysis, which most people do, is kind of sub-optimized because they do the 5 why on the problem, but not the causes. So Toyota knows that. Industrial engineering in handbooks, they know it, and they have it. It's called that little schematic, which I won't do here today, an analysis of all these types of things, where, what, when, who, and how, and you apply why to each one. And that's your data collection plan. So the data collection plan is this.
Exactly.
So that data collection plan is to identify the data to support the causes. And when we get down to this one, it's very interesting when you do the analysis. You know, you can do histograms and control charts. You do scatter diagrams, column charts, pie charts. By way of example, the number one statistical tool used by Toyota is Pareto, which is Dr. Duran, the 80-20 rule. And people say, why is it a Pareto analysis, the 80-20? Because Toyota follow their procedures so well that they're always looking for incremental, Kaizen, little things to improve. So they would look at a process, as we said here, and try to find out any 1 second time 1,000 cars per shift, it's 1,000 seconds. Well, they'd work on that, whereas we sometimes in the West don't always do that. So the important part is collecting the data. I remember a building and construction firm. The manager's name was Sands. We'll call him Sands. We'll call him George Sands, and it was in a quarry where they got sand from. So he came in with the data to prove that was what the cause was. I said, oh, did you? Oh, who collected this? I did. How did you know that was a cause? Oh, it's always been the cause. Oh, has it? Oh. Can we just put that data up onto the whiteboard? And we did all that. And I said, I think your team members collected some data too, your operators and your engineers and your technicians. So we put that data up and we showed it, all the graphs, charts and diagrams. And he sat there, to his credit, he went, oh my goodness, I've only collected the data, what I thought was the cause, but there's other causes. How did you boys and girls know about these other causes? Barry, that's his name, George, because we work in it. We put up with this all the time. We've been telling you for ages. Oh, well, why didn't you tell me? I said, we've been telling you. Oh, now I've got the data. Now I've seen the graphs, charts and diagrams about the causes. So when you're doing that, you're taking away the heat from the blaming the person to the process or the problem. So that will help us later on when we get to the last bit.
Absolutely. I like that, the one that you mentioned earlier, like very small and incremental improvements in like any process that we do, because you do not need necessarily to get it right like 100% first time. And the reality is that like if even a problem is identified and we start like improving that, just for argument's sake, say 1% a day, after 100 days, you have got it completely removed. That's just 1% per day. So you don't need to get it right or solve it on the day dot, but 1% improvement per day.
That's a lot.
In 3 months' time, it's gone. It's gone. So
and it's so rewarding to see that. I mean, I was doing a chicken company in the country New South Wales, and the guy did, I just said about the analysis, and you said 1 improvement per day. He put the disinfectant into the chicken sheds. So when you walk in, you have to step into the liquid because you can't have the nasties on your feet when you go in. Anyway, he presented the Pareto chart, which we just mentioned. He did it back to front. He did the control charts the wrong way. He did the histograms the wrong way. He did everything wrong. And this guy was about 6'6", and he was the local football hero. He went down on the Saturday and got at the newsagent some posted pages, like remember when you were at school, you did a big poster? Yeah. It was about double A3. I don't know what that is. Anyway, he came and he did all these charts and diagrams. He used Women's Weekly things he used the meat and livestock thing. He used chicken things. And I thought, wow, he spent his whole weekend doing these charts, graphs and diagrams, you know, and my goodness. And I looked at it and I started to laugh, but I didn't tell anybody. So when he came up to present, I had one of the managers say, "Oh, he's got the Pareto chart back to front." I said, "He's 6'6", he's 120 kilos. Are you going to say anything to him?" No.
Not today.
Good idea. I said, "So, George, how much are you saving?" He said, "Oh, I'll just get Mary to do that because we're in a team and Mary is my friend." And we went, "Who's Mary?" "Oh, that's right. You're one of the operators there." "Mary, can you talk?" "Yes." So she said, "Oh, we've found out that we lost $56,000 per month on disinfectant." And we went, "Why is that?" So he went to the so-called cause analysis diagrams. He did an event. This is what happened. And he says, "Because we got the wrong measurement. We were told in one shed to use this size little thing, and the other shed, because they're about another kilometre away, used a different size. And by the time we did it, they found out they had all these different sizes of things to put the disinfectant in. And then we said, "Well, why don't we get back to standardising it?" So they did. And Mary said, "Yes, so now we standardise it. We've already implemented it, so we don't need the management approval to put in the solution." And they all went, "Well, what are we here for?" "Oh, we just want to let you know what we're doing." I said, "What's the standard one?" He said, "We found out it was almost like a thimble, not a cup, a thimble." Well, where did you find that? "Oh, we went to the so-called technology, the Australian standards, and they have for disinfecting of chicken sheds.
Yeah.
And there's a thing says this is how much you use." And the management said, "So what's the next project?" I said, "So what are we doing here?" He said, "Oh, I just want to let you know that that's what we're doing." And this big guy says, "Oh, I want to thank everybody. This is the first time I've ever presented in front of management and I really like it." We made him the next facilitator because you see these people grow.
Yeah.
But yeah, you're right. Understanding the causes and all that. Yeah.
Absolutely. Well, and we have got here number 5. I'm reading somebody was right or is right. Well, apart from my wife, who is always right. So let's talk about that.
Why do we exist? I don't know.
Well,
I don't know why I bother.
Let's talk about that.
So Franken, I was doing the Navy down in a certain base in Australia.
Yeah.
And I got to this cause analysis and it was by chance. It was just so unusual. I had all the senior officers and your junior midshipmen and everything there. And I said, when you get to the causes, it's a bit like Frankenfurter. And so all the people in the white were in the front with all the stuff on top of them. And I said, so it's just like Frankenfurter. I want to remove but not the, anyway, when I said that, I said, I want to remove, and straight away, the commander of the establishment for the Navy said, straight away. So when I said, I'll remove and he said, the cause, but not the symptom. Well, all his junior officers and everybody else leant over to say, who said that? It was the boss. So what happens is, when Frankenfurter said to Janet, tell us about it, Janet, he said, I'll remove the cause, but not the symptom. So one of the things that happens is when you get to this point, and I've judged teams, I'll use the so-called the basic cause and effect diagram only. So when you brainstorm this, at BHP, they call this the dead Ned Kelly diagram. So looks like Ned Kelly thing. So they brainstormed all these causes. And what happens is they did the voting and they said that was the cause, major cause and that cause. Yeah. And so when we do the international team judging competitions, we want to know was, did you eliminate that cause? Right. Sometimes there's a little cause over here that it wasn't. We thought it was a cause, but only got 2 votes. We found out that was actually the major cause because we collected the data. Yeah. And all the other part, well, what about these other ones? Oh, they're only symptoms. So Frankfurter says, I'll remove the cause, but not the symptom. So one of the things is when you put it in, and we set up here in regards to this process, where was it here? So when you put in the solution, I was in a foundry. So they put in the solution, and the process was always like this in regards to control chart. And there's always put dotted lines on your control chart because the process varies. It's a process behavior chart. And as you know, in regards to histogram, it goes into the bell curve. Yep. Anyway, when they did it, they put the solution in because they realised through the cause analysis through this one that there was a problem. They put in the solution and the process reduced variation, and then they made the change. And it got down to this. So back to our one this morning, today, in regards to the biomedical one. So they reduced the variation. Once they moved the variation and made it stable, then they did the improvement and controls, and they made further improvements. So as you said, Ali, you can do what Imai said about Kaizen.
Yeah.
So that's the small step. But you want to get through to a situation you can do the breakthrough. So back to our keep, change, create. The Kaizen is usually keeping what you're doing, just follow it. As Dr. Imai said, or Professor Imai said, you will get 15% improvement if you just follow the procedures. So when I was back at BHP Steel and other people, I always say, just follow the procedure. Why? You'll get 15%, as we set up here in regards to the different shifts.
Yeah.
When they go to the different shift, day, afternoon, night shift, if you just follow the procedure, Imai says in his research that you'll get 15% improvement.
Which is a lot.
That's still a lot.
Yeah.
As you said, over the day, over the week, over the month, that's a lot of improvement.
It is indeed.
But the other part is the breakthrough. So if you can do not just, I'll do this in regards to steps, you do this and then you make an improvement and you do more. And sometimes they put in a so-called wedge, the so-called wedge that they see, and that's the SOPs or something.
Yeah.
But somewhere along the line, you want to make a major improvement, the breakthrough. They're not very often.
Yeah.
No, but you do try to get to a breakthrough and improvement. So when I said about the future, Franken and Furte saying that they were right. When you get to that and you put it in, you implement the solution and you try to see if it worked, test against some standards, then keep on doing the monitoring. So when you go to hospital and they look at your thing, they go, I think you have a problem.
Yep.
Monitor it, and then when you finished it and it's all right, you put it back into your procedures.
Yeah.
Train people. They do it. Here's what we're going to do. And then you go back and make sure you do it. And then what happens is, as we know, we do internal audits.
Yeah.
So we've proved that we've made the change. And if it is okay, then we put it into our management system. Exactly. So the management system is the way that we do things around here. And that may be certified to some, you follow your own management system. You may want to seek external certification to something else. And if that's the case, then you get your ticks, whatever those ticks are.
Yeah.
So hopefully in regards to the so-called processes of doing, define, analyse, what's the causes, making sure there's solutions to the cause, implement, and then standardise in regards to DAXIS kind of flow. But I just thought I'd share with you kind of a way and probably put a few stories around some organisations in both factories and offices and, airports and everything else. Everybody uses a different way. Whatever it is, just follow it and you'll make a lot of improvements. Like Imai said, if you just follow the same way, you'll probably get 50% improvement.
Great. No, look, it was very good. It was very good. I myself learned a lot, and I'm sure our audience also appreciate a lot of good stuff that has been shared here. Mike, do you have any good book recommendation for our audience?
Well, it's funny you should say that, Ali. I have my problem-solving book.
Look at that.
Yeah, so you can access this on our website.
Yeah, sure.
It's under product, and it's there. And in saying that, you can print it in A4.
Yeah.
Or you can print it in as this one in regards A5, and it has our DAXIS and methodology. There's another thing which I should point out, that when we did this back in the 80s and 90s, we've been doing this for a while, that people ask us, how come you're using one of the techniques at different stages in problem solving? You can use any technique at any stage.
Yeah.
So one of the things that we did in regards, I'll give you another one, in regards to this process here. So when we collect the data and so forth, and here's the affinity diagrams, that's Kepner-Trigo, of course, and getting to the, as we did here, regards to the so-called basic or process. So one of the things that happens in this problem-solving pocket guide, which is Australian-made.
Awesome.
Yeah. Actually, they rang me up and they said, oh, hello, Mr. McLean, is it? How did you get this passed? Sorry, who are you? I said, oh, we're the Australian-made license people. I said, oh, is it okay? Yeah, it's okay. But you're the first time anybody with a book like this applied for and has received the Australian-made license for a particular technique. Oh, really?
Amazing.
And of course,
Yeah.
as I said before, in regards to keep, change, create, that's in
Yeah.
there. But yeah, that's available on our website, and for a special introductory offer of $9.90 or something.
That's all right.
So it's been used in many organisations, especially those that have a competitive systems and practices, or it respects if they're doing Lean or Six Sigma or 8D or any other methodology to suit their context. It'll blend in because it's following Dr. Deming's, plan, do, study act. So you're studying the process. So it's just one of those techniques. The other one I should point out, which is in there, and I got it out here in regards to what I was involved with. I was on the team, went around the world to do these particular tools and techniques for ISO. There's one called ISO 10009, which is the quality tools. So there's quite a lot in that too.
Awesome.
And Australia was, we did the storyboards. So we put all this into a storyboard. They can do the A3 storyboard, current state, future state. We've got examples of storyboards of applying this to strategy, operations and tactics. And so ISO 10009 is a very good resource. Unfortunately, you've got to buy that from ISO. I don't sell that because it's, and the other ones are too.
No problem at all. Look, I'll make sure that we put a link to your website when we publish this podcast, so people could easily go there. And I mean, that's really pocket size, but that's full of content of like that's in there, and there's a lot in there that people could easily take and apply to their like project or manufacturing that they're doing. So. Great. Mark, it was really great session with yourself. We unpack a lot and we covered a lot of grounds. Thank you very much for coming here today and sharing your knowledge with us. Thank you.
Thanks very much, Ali.
My pleasure.